Okay, before I start, I have really good news. These proofs are insane. So we're going to do a modified proof and not like a proof, you know, like a proof. No. Let's get started. I'm trying to be cool. It's not working. I messed up, so I fixed it. The angle-angle similarity theorem says that if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. And similar, again, means the same in shape, but not necessarily in size. So I could have a small triangle and a big triangle, but if those angles match, they're similar. Why does the third angle not matter? You can think about that for just a second. It's because all triangles add up to 180 anyway, so if two angles are the same, then the third angle is the same. So I'm just needing the least amount of information I possibly need to say that two triangles are similar. Why is this useful? Well, last time I had to tell you that two triangles are similar and then you found some missing information. So today I'm not going to do that. I'm going to show you two triangles, ask if they're similar, and then ask you to find some missing information. But this is going to be an informal proof. So you don't need to do the statement, justification, statement, justification, statement, justification, statement, justification. We're just going to have like, hey, these two angles match, angle-angle similarity theorem. These are similar triangles. Okay. But we're not going to go too far into this. So you're welcome. Okay. So here's where we're going to start. So I have these two triangles. I want to determine if they're similar. I just want to see if they're similar. So right now, oops, sorry. This is already given to me. I just rushed Rod. Sorry. Okay, so right now I have these two triangles and I want to see if they're similar. Let me change color so you can see where my thinking is. Okay, change colors. I got like a tealish color. I don't know. Nope. Okay, so I need to figure out what this other angle is in either one of the two triangles. I don't need to find it in both because if I have 90 degrees already and if I had one other one that matched, I'd be good. So let's just see if that matches. So I know that, let's just take this bigger triangle. I know that 64 plus 90 plus the measure of angle K has to equal 180 because all triangles add up to 180. We know that already. That's from last trimester. So these two together make 154. And then if I subtract 154, I get that the measure of angle K equals 26. Okay, which means that I have angle C and angle K match and angle D and angle G match. So I would say yes by angle-angle similarity theorem. And that would be my answer. Now, AA squiggle means angle-angle similarity. Okay. So I want to determine whether these two triangles are similar. Now, this is harder because there's no numbers at all. But I can still do this, I promise. Okay, so first of all, where are the two triangles? Well, here. There's this little triangle right here, BCD, and then there's this bigger triangle, ACE. Do you see them? They're there. Okay. Hopefully this pencil erases. Great. Okay. So this is basically going to be given information is that these two lines are parallel, right? And hopefully we've learned by now that whenever we have parallel lines, we kind of want to extend them, right? Have you learned that yet from all of our proof land stuff? Well, if I extend these two lines, then I have down here, I have a transversal, a train track, cut by two parallel streets. And so I know that this angle right here and this angle right here are the same. Why are they the same? Do you remember what these angles are called? It's been a hot minute, right? These are corresponding angles. So this is the corresponding angle theorem. And again, we're not writing a formal proof, so I don't have to say angle E is congruent to angle BDC because of the corresponding angle theorem, but I could if I wanted to. Like if I really wanted to. I could do this. Okay, and then I can come up here and do the same thing up here. So I have one transversal, it's flat, so it kind of looks weird, cut by two parallel lines. So this one and this one are the same. Same reasoning, right? It's also the corresponding angle theorem. So we would say yes, because I have two angles in one that are congruent to two angles in the other. Also, this one's automatically the same because it's reflexive. I didn't even need to do this other one, but I might as well have, right? So if you did reflexive, that's totally fine too. So by the angle-angle similarity theorem. So we're good. We did it. You can do this too. Let me just double check there's nothing else. Yeah, let's call that it. So hope you learned something. If not, email me. I want to help you. And I hope that eases your mind a little bit. So, okay, I'll see you in the next one.